Class, what is going on? We are starting to work with the law of cosines now, okay? So far, we have gone over SOHCAHTOA, we've talked about area of triangles, we've talked about the law of sines and why we would use the law of sines. And so now we're going to talk about the law of cosines, because there's some situations where the law of sines doesn't work. So, first things first, I'm going to give you guys the formula right here for the law of cosines. And what I'm going to end up doing, I think I'm going to make a separate video just on the proof, if that's something that you're interested in. But I don't want to make this video too long that you guys will get frustrated and yell at me. Okay, so we're going to talk about the law of cosines. We're going to give you the formula. And then again, if you would like to see the proof of it, you can watch a separate video on that. Alright? So, things that we need to understand here. Let's say that we're trying to get angle C. Alright? Angle C. Well, then that means that I need to write C squared equals A squared plus B squared. Oh my gosh, that looks a lot like the Pythagorean theorem. But we need to subtract 2AB cosine C. Alright, so you might be asking, Mr. Rabins, this is so confusing. How am I going to remember this? Alright, things that you should absolutely be noticing right now. Right here, these two pieces. Alright, depending on what you're solving for, whether you're solving for an angle or a side, that's probably where you would like to put that pairing, right? That angle and side pairing should always be kind of opposite of each other. Alright? Because then the rest is kind of easy, I hope. It's the other two sides, right? So A squared plus B squared, and then minus 2 times the product of those sides. Alright? So again, we figure out which one to use, or which angles to use. That's not the right way either. Which setup to use, right? Which way that we're going to write this formula? By looking for our angle side pairing. Alright, and then what do I mean by that? Well, let's say we were looking for angle B instead, right? Well, I could rewrite this a different way. If I was looking for angle B, well then I would want B squared to be on the side by itself, right? So I could write B squared is equal to, and then I would just use the other sides. A squared plus C squared minus 2AC, and then cosine B. Hopefully that makes sense, right? Once you figure out the angle that you're kind of looking for, that dictates which format or which formula you're going to write. Okay? So let's jump into this. Again, blind faith right now on this formula. If you want to watch a video on the proof, I will post that in a little bit. Alright? So, here we go. Solve this triangle using the law of cosines. We have two sides and an angle, so we're going to sketch a picture. Maybe something like, oh, I don't know. We'll call this A, B, C, and then we can label some things. We know that we have a 20-degree angle. We know that the side across from A is 11. Ooh, this is not to scale. And we know that B is 5. Alright, so already I can tell that my picture is not great. That should not be the end of the world, though, guys, as long as you understand that this is not drawn to scale. But we remember, hopefully, solve means we want all the information about this triangle. So we need measure of angle A, measure of angle B, measure of angle C. We also need A, B, and C. Alright, now let's fill in what we have. We know that C is 20 degrees, so I put that in. I know that A is 11, lowercase a, side A, and then side B is 5. So, first thing to notice, we cannot use the law of we cannot use the law of sines because we don't have an angle pair. An angle side pair, right? I don't know the side across from C. I don't know the angle across from B. I don't know the angle across from A. Alright, so if I don't have a pair, then I can't use the law of sines. So, law of cosines, here we go. Now notice here, we are looking for an angle here, but if I have this angle C and I have two sides, well then hopefully we can recognize right here, I have everything over on this side, which means I can solve for this missing side C. And that's what we're going to do using the law of cosines. So I'm going to use my formula. I'm going to say C squared is equal to one of the sides squared plus the other known side squared minus the product of 2 and those sides, and then multiplied by the cosine of that angle you have, so 20 degrees. Alright, and guys, this goes straight into the calculator. Seriously, I mean, you don't have to show me any work, you just need to, well, you need to show me this line, but after that, just plug it in. So what am I going to do? I'm going to say 5 squared plus 11 squared minus 2 times 5 times 11 times the cosine of 20, and I get 42.63. Let me just double check. Yep, we're in degree. Okay, so, last thing we need to remember here is that is C squared. So C squared is about 42.63, or when I square root this answer, I get that C is equal to 6.53. Now, for writing an answer down, I want it to 2 decimal places, 6.53. That's awesome. I need to teach you a new function on your calculator, or hopefully some of you guys know about it, but we might as well use this if we can. Down towards the bottom, right above the on button, is this STO. That stands for store. And what we're going to do, guys, is we're going to actually, because we don't want to use 6.53, we want to use 6.52945723 throughout the rest of the problem. So what we're going to do is we're going to store this. So we hit store, and it brings up this menu, answer stored as, you can call it whatever you want. I'm just going to call it C, because it is my C value. Alright, so I'm going to store as C, and now I can do whatever I want. 7 plus 8, 4 squared, and when I go and I hit second C, it brings back that number for me. Okay, so now I have that value stored in my calculator. Alright, so this is good. This is really good. So what we can do now is we can say, well, I know that this is 6.53, and now what do you guys notice? Oh, sorry, off the page. I now can write that this is 6.53. I now have a pairing. I now can use the law of sines. Whenever I can use law of sines, I want to use law of sines. Now we need to be really careful here, and this is a subject for another video that we're going to do in a couple of days, but we need to be very careful, and we need to make sure that we get the smallest angle, or the next smallest angle, depending on size and what you're given. But right now that means, well, if I have a side of 5 and I have a side of 11, which angle is going to be smaller, A or B? Hopefully you said angle B. Angle B, again, if we remember about triangles, smallest side across from smallest angle, middle side across from middle angle, etc., etc., okay? So I know that because 5 is less than 11, that B is going to be smaller than A, which means I need to get angle B first. And that's what we're going to do now. So now, again, I can use the law of sines. I can say that sine of 20 over 6.53, but remember, we're not going to use 6.53, we're going to use C, equals sine of B over 5. And now I can cross multiply. So I get 5 sine 20 equals 6.53 sine B. And then, of course, what do I have to do? I need to divide by 6.53. Alright. Alright, so we're getting there. We're getting there. We go to the calculator now, right? And we know we're going to do 5 sine 20. We know we're going to divide that by, remember, I'm going to use letter C. And now I know that sine B has to equal 0.2619, okay? So sine of B is equal to 0.26. But again, what do I have to do? Because I don't want, or I'm looking for an angle. How do I get an angle from a ratio? I actually have to use the inverse sign, right? So I'm going to have to take second sine of this answer, of this ratio, to get my angle of 15.18. So B is equal to 15.18. All right? So I can write that in. And then what do we say? What can we do? Do we have to do any more crazy calculations, or can we just say that if we have two angles of a triangle, we can always get the third, right? So we would do 180 minus 15.18 minus 20, and we are good at 144.82. 144.82. Okay? So there you go. We had to use law of cosines here. Why? Because we did not have an angle side pairing. All right? So let's take a look now at our next one. Okay. Draw another picture. A, B, C. Again, it doesn't really matter. Just make sure you draw a triangle so you can at least understand like the side relationships, angle side relationships. A is 9, B is 7, and C is 5. All right, so here we go. Now we have all three sides. Interesting, interesting, interesting. Do we have an angle pairing? No, we do not, which means we need to use law of cosines here. We need to use law of cosines. And again, I want to get that smallest angle first. All right? I want to get that smallest angle first. So that means I'm going to have to get angle C. All right? Angle C is what I'm looking for first. Well, if I'm looking at angle C, and I have C, then hopefully you agree with me that I'm still going to write my law of cosines formula using this formula as written, right? Because I want to get angle C. All right? So we now know, and this is going to be a little bit goofy, but instead of writing C squared as like C the side, I'm going to say that 5 squared is equal to 7 squared plus 9 squared minus 2 times 7 times 9 cosine C. All right, and again, what's important for you to recognize? That the 5 and the C, angle C, are across from each other. All right? And now we just go, right? Well, in something like this, it's a little different. Recognize that these are just going to be subtracted to the other side. All right, so we're going to do 5 squared minus 7 squared minus 9 squared. So 5 squared minus 7 squared minus 9 squared. And we now know that the left side is going to be negative 105. All right, and again, what did I do? I just moved these over. What do I have to do now? I can use algebra, right? I can solve for cosine C. I would divide by negative 2 times 7 times 9 on both sides. So be really careful when you do this. Make sure that if you divide, you're putting all of these underneath, right? So negative 2 times 7 times 9. Why am I? Oh yeah, my bad. I'm doing it right. Okay, so now I know 0.83 is equal to cosine C. All right? Okay. Well, again, we want the angle from a ratio, so we need to use inverse cosine of our answer, and we get that angle C should be 33.56 degrees. All right? And so I probably should have already made a list. My bad, guys. I'm going to have to go down here. So measure of angle A, measure of angle B, measure of angle C, A, B, C. And we knew A was 9, B was 7, C was 5, and now we have angle C is 33.56 degrees. All right? Well, now we're going to go in order again, right? Smallest to biggest. So what's going to be our next smallest angle? Well, we just found angle C. So that was across from the smallest side, which means I need to get angle B next because it's across from the next smallest side. So now we're going to move to law of sines. Why? Because we have an angle side pairing. So I'm going to say that the sine, ooh, and my bad guys, one more thing. What should we do with this on our calculator? Because we don't want to round it. We're going to store this. This was angle C, so I'm going to store it as C again. All right, my bad. I just wanted to make sure to get that done before I moved any further. So now I know sine of 33.56 over 5 is going to equal sine of B over 7. Cool. When we cross multiply, we would get 7 sine 33.56 equals 5 sine B, and of course then I'm just going to divide by 5. Alright, so on the calculator that would look like 7 sine, I'm going to use my angle C, and then I'm going to divide by 5. And now I know that the sine of B is equal to 0.773, so what am I going to have to do to get angle B? Well, I'm going to need to use the inverse sine. So, inverse sine of answer, and we get 50.70. And that was angle B, so 50.70 degrees. Alright, lastly, what do we do if we want to get the last angle? Well, we just do 180 minus, right? So 180 minus 50.70 minus 33.56, and we get 95.74. And there you have it. Okay, so that is practicing using law of cosines, and I'm probably going to say it again on the next page, but again, hopefully you understand and are recognizing we need to use the law of cosines when we do not have an angle pair relation or pairing. Okay, once you have an angle side pairing, then you can go ahead and you can switch to law of sines. But again, what do we have to do? We want to go in order from smallest to biggest. All right. So, one more page, and this is not something that we're like trying to have you guys memorize, but it is something just to be on the lookout for, okay? Like if I've taught you anything, it's that to use the law of sines, you need to have a angle side pairing. So when we look at something like side, 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 are there any angle side pairings? No, there are not, which means you have to start by using cosines, law of cosines. Okay. How about side angle side? Well, once again, I'm looking for this side, which is awesome, but could I use the law of sines? Do I have an angle side pairing? I don't. So once again, cosines. All right. Now, angle side angle, I don't want you to overthink this, right? Like currently, I don't have enough information, but what is always true if you have two sides? Well, then you always have the third, right? So we know that this would be 120 degrees, and then, oh my gosh, what do you have? You have an angle side pairing, so you can absolutely use law of sines. Angle side? Let's think about this. Oh, do you have an angle side pairing? Absolutely you do. You know that you could find either one of these other sides because you have that angle side pairing, so this would be sines. What's going on this last one? HL. So we have a right triangle. Let's think. Well, we definitely have an angle side pairing, so we could use the law of sines. But couldn't we also... I think we could also use law of cosines. If we wanted to, we could, yeah, because we have this angle and this side, we could get this other side using cosines. What's even easier than using sines or cosines? Well, we could use the Pythagorean theorem. Or we could even, if we wanted to, because we have two sides, we could get some angles using inverse trigonometry. So this, because it's a right triangle, we could use so, ka, toa. So when you have right triangles, you have a bunch of options, okay? So, to finish up this video, we need to remember some things about triangles. The first one you guys know, the sum of three interior angles is always 180. You got that. These next three are a little bit different, but are fairly important to understand. How many acute angles could there be in a triangle? Is it possible to have one, two, three, or like what's the max? And hopefully, like when I think of this one, I think right to an equilateral triangle. I know that an equilateral triangle has 60, 60, 60, so I know it's possible for there to be three acute angles in a triangle. When I think of how many obtuse, well, as soon as you have an angle that's bigger than 90, you know that those other two angles are going to have to be acute. So you know that there can only be one obtuse angle in a triangle, right? If there is a 120 and a 130, that's more than 180 when you find the sum already, without even adding the third. So that would not be possible. And then lastly, how many right angles? Well, again, you can't have a 90 and another 90 because that's already 180. So that is no good. Okay, last thing. The sum of two sides of a triangle must be, I don't know if you guys remember this one, but the sum must be greater than the sum of the two sides must be greater than the third side. And a good example of that would be something like this. If I said this was 5, and I said that this was 2, and maybe this is 2, well, I would not be able, you would not be able to ever form a triangle here, because the 2, if you tried to get it as close as possible to this other 2, they would end up lying flat on that third side of 5. Okay? So this is one last little property that we need to remember about triangles. Alright, so here we go. This is our video on the law of cosines. I'm sorry that it was a little longer than I wanted to, but I hope you guys are understanding how to use it. Alright, have a good one.